So over the past 2 years, I've been tutoring secondary school students math, E-math and A-math, and I've helped many of them score A1 for their exams and even the O-levels. And today I've decided to give you a full crash course that I've prepared for one of my online classes that I conducted in the first year of teaching that will basically reteach you every single fundamental concept and every single thing that you need to know in vectors. This full crash course will cover all the concepts as well as TYS questions that I went through with my students in specific during class. And as you can see on the screen over here, these are the specific timestamps as to the specific portions of the video. So if you want to jump straight to any specific portion, all you got to do is you just go and click on the description underneath this video and you see all the timestamps. Just click on the specific timestamp and it will bring you directly to that portion. And if you want my full handwritten notes to everything that I created in this video, all you got to do is to go and click on the link in the description below, fill out all of your information details over there, and I'll send you the notes that I created for this video completely for free. I'm on a mission here to help as many Singaporean students score A1 for math, both E-math and A-math. So subscribe to this channel if you're new here to get updates whenever I release more new crash courses in the future just like this. And without further ado, let's just jump right into the vectors crash course. Today we are going to talk about vectors. So this lecture will cover everything you need to know about vectors for the entire E-math syllabus. And I've condensed everything you need to know into these 7 points, of which I'll go through all of them in today's lecture. So let's just start off this thing by defining what exactly is a vector. Now, a vector is a quantity. Okay, just remember it's just a quantity. But this quantity has two features to it. It has a magnitude. So you can think of magnitude as like a value. And then it has direction. So it's either positive direction or negative direction with respect to a point. So for example, a vector can be represented as such. Let's say I have points A, I have point B. I have 2 points, right? And point A is my starting point. So I start here and then I end here. So there is an implied direction of which I'm traveling from A to B, right? So my direction in this case is A to B. And my magnitude is just the distance, the value of the distance that I travel from A to B. So what's the value? So let's just identify this as a right angle triangle. And then let's say this is X units and this is Y units. That means my magnitude of which that I travel is just square root by Pythagoras theorem is just x squared plus y squared square root. Right? So there is a direction and a magnitude. And you can actually represent both of these at the same time by saying that my vector is just AB. AB of which is x, y. Like that. So A is the starting point, B is the ending point, and you can represent it by this. And sometimes, instead of writing AB, we may represent this vector as A like that. A with a dash at the bottom. So this is what essentially a vector is. It's a implied direction that has value. So the length of A, the physical length of A to B is the magnitude, or it represents how big the vector is, what's the value of the vector. And the direction is essentially just from A to B lah. So with that being said, a vector, how do you find magnitude of a vector? Magnitude of a vector, like the actual magnitude, is essentially just the length of the line. The length of the vector. And we will always use this symbol. In this case, the symbol for length magnitude will be modulus AB modulus. So this will be the symbol that you will always use to represent the symbol to represent magnitude of a vector. Or in other words, you can also write this as xy. So this is actually just square root
x squared plus y squared. Just like that. So this is how you always find magnitude of a vector, is by using this symbol over here as well as using this equation over here and just submit the values. Alright, and then the direction is always just from where to where. So in this case, it's from A to B. Right? From A to B. That's the implied direction. Okay, so that we have covered two things already. What is a vector? How do you represent a vector? Now let's move on to the next point, which is position vectors and coordinates of a point. So I'm gonna write it over here. Position vectors and coordinates of a point. Now I'm very sure that you have probably seen a vector that looks like this before, right? OP, OM, OA, OB. Now in vectors, as long as the vector starts with an O, it means that your vector's starting point is 0, 0. That means it's the origin. So for example, if we look at this y-x plane over here, this is y, x, 0. Now if this is A, that means here to here is my OA. Right? If this is B, that means here to here is my OB. If the vector starts with an O, as you can see over here, it all takes reference, the origin or the start point is always with reference to the origin O. Okay, so that means, right, if let's say my coordinates of A here is, let's say, xy, that means OA, if A is xy, that means my vector OA is just xy, like that. You will represent OA as such. So if I give you an example, let's say B is -3, 5, right? That means since B equals to -3, 5, therefore OB can be represented as -3, 5. And the length of OA is simply just x squared plus y squared. And the length of OB is simply just 93 squared plus 5 squared. Just like that. So position vectors are just vectors which the starting point is the origin, but it still behaves like any other normal vector. So just bear that in mind. Position vectors are just vectors whose starting point is the origin OO. Just like that. Alright, so that is how you link position vectors to the coordinate of any point on the line. Any point in the Cartesian plane. So that is that for the third point. Now let's talk about the next point, which is equal, negative, and zero vectors. So the third point over here, equal, negative, zero vectors. Now, what do we mean by two vectors are equal? So for example, let's say we say AB is equal to CD, right? We say that vector AB is the same or is equal to CD. What does that mean? It means two things. It always means two things. it means that AB and CD have the same magnitude. So that's the first. Same magnitude. And at the same time, A, B, and CD have the same direction. So what does this translate into? Since they're the same magnitude, that means their length of vector is the same. And since they have the same direction, they are parallel to each other. So for example, in a yx plane for over here, yx, let's say here is A, B. Okay, let's say here is AB. AB. This is my vector AB. For CD, for AB to equals to CD, that means CD must be parallel to AB and it must have the same length. So that is what essentially equal vectors are. Equal vectors have the same length, which is the same magnitude, as well as the same direction, which means they are parallel to each other. Okay, so these are equal vectors. How about negative vectors? So for example, let's say we say that vector, let's say we say that AB, or we say that DCDEF is the negative vector of AB. Or essentially we can express it as AB equals to negative EF. Or okay, we say it as EF equals to negative AB. So what does that mean? It means two things again. So it always just comes back to magnitude and direction. It means that AB and EF, they still have the same magnitude, because magnitude is dependent on the line of the vector, but in this case the length of the vector never change. So they have the same magnitude, but AB and EF are in opposite directions. So in vectors, whenever you add a negative sign in front of a vector, the entire direction of the vector flips. So I'm just going to reference to this drawing over here. I'm going to paste it here. That means in this case, this is our original AB, right? Original AB. Now we have EF. Let's say this is E, this is F. So EF now is negative AB. That means EF is now in this direction. So this E, F. F. EF is not in the same direction as AB, but they are the same length as AB, as you can see, right? They are now in opposite directions, but they have the same length. Therefore, they are the same magnitude, but they are just in the opposite directions. Okay, now last one will be zero vectors. Zero vectors, or sometimes we call them null vectors. What does this mean? Null vectors or zero vectors, it all comes down to back to the same 2 points, right? Magnitude and direction. So for zero vectors, have a magnitude of 0. and then there is 0 vectors have no net direction. So when will we use this concept of 0 vectors? We will use this concept of 0 vectors used when, okay, let me rewrite this. We will use when we add two vectors of same magnitude but different direction together. So for example, we use our earlier on case study. Let's say AB is 2, 3. Right? Example, AB is 2, 3. And since EF is negative AB, that means EF equals to negative 2, 3. Therefore, when we add AB to EF, we take 2, 3 plus negative 2, 3. So we are essentially taking 2, 3 plus minus 2, minus 3, which we get 0, 0. And therefore, this is a 0 vector. That means there is no resultant vector. And no resultant vector can be expressed as 0. So this is the concept of 0 vectors. So essentially, if you take this, you plus this, you get no more vectors. You get 0. Your vector is 0, 0. Okay, so that is equal, negative, and 0 vectors. Now, moving on, the next one will be addition and subtraction of 2 vectors. So the next section over here will be sum and difference of vectors. So I'm going to write the sum one over here and then the difference here. So sum of vectors is just using common sense, really. If you are confused, just look at this drawing over here. Let's say A, B, C. Okay? Now, assuming I want to walk from A to B, right? I am at A, my start is here, my end is here. I want to walk from A to B. I can walk from A directly to B, right? That's my shortest path from A to B. But at the same time, I have another route I can take. I can walk from A to C first. So I walk from here all the way until here, right? And then once I reach C, I then walk from C to B. So I walk from here towards here to here. Instead of walking from A to B directly, I can walk from A to C, then C to B, right? So, but the thing is that even if I take the first route or the second route, eventually in the big picture, I am still going from A to B. It's just that when I walk from A to C and then C to B, I'm taking a longer route. But fundamentally, it still doesn't change my start point and my end point. My start point is still A, my end point is still B. So what does that mean? I can represent A to B, my route that I take from A to B, as me walking from A to C, then C to B. So this is addition of vectors, whereby you, instead of going straight from the start point to the end point, you take a different route that still helps you to go from the start to the end. It's just that it probably may be a little bit longer. And therefore, this point over here and this point over here must be the same. They must match. Why? Just look at this drawing over here. You walk from A to C, right? This is the vector AC. And then once you reach C, right? C now becomes C is the end point of your first vector. But at the same time, it's the start point of your second vector from C to B. So therefore, your end point of your first vector must match the start point of your second vector. So therefore, this must always be the same in order for you to add two vectors together. So this is the concept of sum of vectors. And then for difference of vectors, this one, difference of vectors, so we are going to use this analogy over here again. But I'm going to do reference to the position vectors. So let's say this is O, this is A, this is B. Right? This is OA, AB, and then OB. Now, if I want to go from A to B, right? So if I want to go from A to B, I can go from A to O. So I can go from here to here, and then I can go from here to here, right? So I can go from A to O and then O to B. Agree? Right? This is still using addition vectors. But at the same time, I know that I can OA or AO is just negative OA. Right? These two are exactly the same. These two are exactly the same. Right? Because you see, OA is this direction. Therefore, negative OA will be this direction, which matches this. They match, so they are exactly the same. So now I can express this as plus OB. That means it's just OB minus OA. So in order for you to subtract two vectors to get one resultant vector, always remember your first point must be the same. Your first point must be the same, and then this point will match with this point, and then this point will match with this point. So for difference of vectors, if you can't really visualize it, just memorize. But for the sum of vectors, please make an effort to go and visualize what is happening as what I've explained earlier on. Alright, and with that, we can move on to the next one, which is scalar multiple of vectors. Okay, so scalar multiple of vectors, what does that mean? So number 5 will be scalar multiple of vectors and parallel vectors. So now consider this situation. If AB equals to 2 of CD, what can you say about these two? You can say that AB is parallel to CD, right? It's still parallel to CD, right? Because they are equal to each other. But then at the same time, AB is twice the length of CD. So that means it kind of looks like this, right? This is AB. Then this shall be CD. They have the same direction, they are parallel to each other, but the length of CD is half of that of AB. So therefore, for scalar multiples, it says that if A, here this is A, B. So if A equals to KB, where K is a constant, a real constant, that means that you can say that A is still parallel to B, and you also can say that A is K times the length of A is K times that of B. That is all what this is saying. That means A has has K times magnitude of that of B. Alright, so that's one thing to note. And then another thing to note is that, let's say we have A equals to KB, but let's say K is negative and then K is positive. For example, 2. For example, negative 2. If you have a negative in your scalar multiple, this will flip the direction of B. And since this flips the direction of B, they will become opposite directions. This, and then for the top one, it will remain in same direction. Right? So for example, let's say I have let's say AB is 2, 4. Right? And then CD is negative 1, negative 2. So how do I link these two together? Let's say AB equals to negative 2 CD. So 2, 2, that means equals to negative 2, negative 1, negative 2, which gives us 2, 4, which is therefore AB. So if you have a negative sign over here, you will multiply inside your vector, and this will flip the direction of the vector. So instead of it being negative 1, negative 2, it becomes positive, and the whole entire direction of the vector will flip and will change 180. So that is the analogy of scalar multiples. Is that scalar multiples suggest that two lines are parallel to each other, but parallel, or two vectors are parallel to each other, but parallel doesn't mean same direction, right? It can be parallel just like that, but it can be in opposite directions as well. It can be one going here and then one going here, but they are still parallel to each other. So do not be confused by parallel vectors and vectors that are in the same direction. A vector can be parallel to another vector, but they are in opposite directions. Okay, so do not be confused by that. And the last point that I will go through is this thing called translation of vectors. So for this point, it requires a lot of visualization, and this one is often tested as well. Translation of vectors. So the definition of translation, right? It refers to the moving, can think of it as moving of all points, or you can think of moving of the entire vector in through the same distance and direction. Okay, don't say vector, moving of all points on the vector. Yep, that means, right, let's say I have an original vector of, let's say, OQ. Let's say originally OQ is 2, 3. Okay, so that means my Q is 2, 3 lah. Let's say I have this. This is my y-x plane. YX. This is origin O. Let's say Q is here. Q is 2, 3. Then this is my original vector. Then now I say, okay, I translate OP or OQ by 3 units to the right and then 4 units to the top. So that means I move this whole vector by 3 units to the right. So I move this by 3 units to the right. This one will become here, right? It will become Q2 plus 3, 3. And then I move upwards by 4 units. 4 units upwards. So that means this one will come here. Becomes 2 plus 3, 4, 3, 3 plus 4. So this one becomes 5, 7. right? So what does this mean? Now the position vector of Q, it becomes OQ now becomes 5, 7. So what translation means, right, is that you're just moving a point. Let's say you are moving point Q along the x-axis and the y-axis. And if you move the entire vector OQ, let's say a translation can, okay, basically a translation can be represented by a column vector. So translation of a vector can be represented by HK, where H is the movement along the x-axis and where K is the movement along the y-axis. This means that if, let's say, I have my vector again OQ and it's 2, 3, and I want to translate it by, as in, let's say I want to move it, I want to move OQ to the right by 3 units and to the top by 5 units. That means I will need to add a column vector of 3, 5 to Q. So this one will becomes plus 3, 5. And then this one becomes 5, 8. So my entire vector OQ will undergo a translation. And it will move to the every single point on the line of the every single point on the vector of OQ will move to the right by 3 units and to the top by 5 units. So that is the analogy over here. Okay, not to confuse you, I'll just put 7. Here I up by 4 units. So just think of translation as moving of the entire vector to the left, to the right, up and down by adding a column vector to it. And if you need some more clarification, you can always reach out to me in the group chat, and I will try my best to re-explain this section if you don't understand, because this section is extremely important. Okay, with that, this is everything you need to know about vectors, and now we will head on to do the lecture questions. Okay, so let's jump right into it. For question 1, OAB is a triangle, C is the point on AB such that AC is 1/3 of AB. OA is A and OB is B. Find AC in terms of A and B. Okay, for question 1, you realize that, okay, I'm just going to draw this triangle out over here. OAB. Here is A. Notice the direction, and then here is B. And then they say that AC, so here is point C. AC is 1/3 of AB. So this is 1 unit, and then this is 2 units. Okay, so AC. They want us to find what is AC. So obviously we wouldn't be able to find AC. We cannot find AC directly, right? We need to find AB first, and then we work backwards to find AC. So let's find out what is AB first. Now, so we can start by saying that AC is 1/3 of AB. And AB, if we want to walk from A to B, what other direction we can walk? We can walk from A to O first. So we walk from here to here, and then we walk from here to here. So A to O, and then O to B, right? And if I were to see that the question give me OA, they never give me AO. So what must I do? I have to flip it. So I have to flip OA to become negative, AO to flip it to become negative OA plus OB, which then becomes my subtraction of vectors. Therefore, the answer is just equals to OB is B, OA is A. So it's 1/3 bracket B minus A. And this is the answer for part A. Then in part B, they say D is the point on OB such that OD is to DB is 1:3. So for example, let's say just imagine here, this is D, this is 1:3. Show that OA and DC are not parallel. So show that these two lines not parallel. How do we show that two vectors are not parallel? To show two vectors are not parallel, the two vectors cannot equal to each other, right? So therefore, we can say that first thing, let's find out what is DC, right? So now we know what is OA, OA is A. So now all we got to do is to find out what is DC. Then we try to express DC as OA, and then we realize that we cannot, and therefore it is not parallel to each other. So let's find what is DC first. So OD is to DB is 1:3. So obviously we wouldn't be able to find OD directly, but we can find what is OB, right? So this means that OB is 4 units, because OB is just OD plus DB ma, you add them together. So therefore OD is 1/4 of OB, as you can see. OD is 1/4 of OB, and OB is just, so if you want to walk from O to B, you can just take O to A plus A to B, right? If you want to walk from, I repeat, if you want to walk from O to B, you can walk from O to A and then A to B, right? So this is what you can do. You can walk from O 1/4, so you walk from O to A, and then you walk from A to B. So this is AB. So it becomes 1/4 of A plus, since AC is 1/3 of AB, that means this is 3 times 1/3 of AC, which is 1/4 A plus B minus A. And this just gives us a very nice expression of 1/4 A minus 1/4 B. Okay, so now our job is to show that DC is not parallel to OA. That means DC cannot equal to K of OA, right? Because they must not be parallel to each other. So our first job is to figure out what is DC. And given that OD to DB is 1:3, we can conclude that here is 1 unit, here is 3 units. So the entire length of OB is 4 units, right? And since OB is 4 units and B is 4 units, that means OD is 1/4 of B, right? So here to here is just 1/4 of B. So now how do we find out what is DC? DC, I'm going to annotate it in green. DC is just walking from D to O, O to A, and then A to C. Do you see that? If you want to walk from D to C, you can also walk from D to O, then O to A, and then A to C. Right? It's just walking another like bigger round. So therefore, DC is just walking from D to O, then O to A, and then A to C. But we have OD and we don't have DO. So we need to flip this. So it becomes negative OD plus OA plus AC. Right? So this becomes negative 1/4 B plus OA plus AC. As you can see over here, AC is 1/3. 1/3 B over A. 1/3 B minus A. And then if you expand everything out over here, you should get negative 1/4 B plus A plus 1/3 B minus 1/3 A. And this should give you a very nice value of 2/3 A plus 1/12 B. And therefore, since DC, which is 2/3 A plus 12 B, cannot be expressed as K bracket OA, where OA equals to A, DC and OA are hence not parallel. Shown. So this is your standard explanation every single time you answer this type of question where you're trying to prove that whether two vectors are parallel to each other or not. Since one cannot be expressed in the form of another via a scalar multiple, they are not parallel to each other. And that is the analogy for this question over here. Alright, moving on, question 2. Position vector of point A is 1, 5. So immediately what I will write is I will say that OA is 1, 5. And I also can tell that the coordinates of A is 1, 5. Likewise for B, position vector of B is -5, -2. That means B is -5, -2. So therefore, in I, they say find the value of AB. AB is just OB minus OA, right? If you remember your subtraction of vectors. Therefore, it's just -5, -2 minus 1, 5, which gives us 96, -7. That's for this answer. I. Now they want us to find the length of AB. So just plug in your formula, 96 squared plus 97 squared, which will give us 85. And then if you key into your calculator and you express in 3SF, you will get 9.22 units. 3SF. Okay? Next, I. They say given that ABA equals to 2AC, what is C? And we know that the coordinates of C, we will derive it by finding OC, right? We need to find the position vector of OC first. Then we will use that as the coordinates. So how can we manipulate this into giving us what we want? BA, so in part I, we found that AB is this, right? Therefore, BA is just negative AB, right? You just flip it. So equals to negative 96, 97 equals to 6, 7. Therefore, 6, 7 equals to 2AC, which equals to 2 bracket OA, OC minus OA, right? So 6, 7. And then we know that OA is 1, 5. So 6, 7 equals to 2 OC minus 2 OA. 6, 7 equals to 2 OC minus 2, 1, 5. So 6, 7 equals to 2 OC minus 2, 10. And then we can bring this to the other side. We get 2 OC equals to 6, 7 plus 2, 10. So 2 OC equals to 8, 17. Therefore, OC is 4 and 8.5. Hence, your coordinates of C is 4, 8.5. That is the answer over there. Okay, then now B, I. P has a coordinate of 8, 2. So therefore I know that the position vector of P is 8, -2, where P is 8, -2. And PQ is 4, 3. Okay, so now they want us to find the equation of line PQ. So equation of line is, I need two things. I need gradient and I need one pair of coordinates. I need these two. So what is the gradient of this line? Now there's a hack for vectors, is that the gradient of the line, right, is just taking, okay, wait, never mind. Now, how to find the gradient of PQ, we need the points P and points Q, right? So P is 8, -2, but we don't know what is Q yet. Q equals to something, something. So how do we find Q? We take this. So we know that for PQ is just OQ minus OP. So we sub in the values, we have 4, 3, right? 4, 3 equals to 8. This is the unknown. So we have OQ minus 8, -2. Therefore, OQ is just 4, 3 plus 8, -2. And this should give us 12. Let me check. Negative. Negative. This should be negative. Negative. So this should give us -5. Therefore, my Q coordinates are 12, -5. So now I know my P. Now my graph looks like that. YX. XY. This is P. 8, -2. Okay, wait. P. 8, -2. And then I have my Q. 12, -5. So this is how my graph looks like. So how can I find the equation of this line? I need to find the gradient. Right? Therefore, gradient of PQ is y2 minus y1 over x2 minus x1. I get, let's say I put -5 minus -2 over 12 minus 8. So I get -3 over 4. Right? Hence, equation of line PQ is y equals to -3, 4 x plus c. I sub in any one of the points. I sub in 8, -2 into equation. I get -2 is -3/4 bracket 8 plus c. Right? And then I get -2 is 96 plus c. Therefore, c is 4. Hence, my equation of line PQ is y equals to -3/4 x plus 4. That is the answer over here. Okay? And then I find the coordinates of the point of intersection between PQ and RS. So PQ is y equals to -3/4 x plus 4. Right? RS is 2y minus 4x equals to 19. If we rearrange this, we get 2y equals to 4x plus 19. And then we get y equals to 2x plus 19 over 2. So this is my first equation. This is my second equation. So to find point of intersection, let 1 equals to 2. Therefore, -3/4 x plus 4 equals to 2x plus 19 over 2. And then you sub in your values, you get 2, 3, 4x equals to 19 over 2 minus 4. So 234x equals to 8, 16, 9, 9, 9.5, 5.5. Therefore, x is 5.5 minus divide by 2, 3 over 4. And you should get, let me check, divide by 2, 3, 4, you should get x equals to 2, right? And then you sub x equals to 2 into either one of the original equations. So let's say we sub into 2, y equals to 2 bracket 2 plus 19 over 2. And you should get 19 divided by 2. Okay, and then you get, wait, apologies, this should be negative. You should get a negative number. Oh yes, this is 4 minus 19 over 2. So you get a negative number over here. Okay, it's negative 2. So it's negative 2. And this therefore should be 5.5. 5.5. Yes. So therefore, my points of intersection, the point of intersection between PQ and RS is therefore just negative 2, 5.5. That is the answer over there. Okay, now question 3. They say A is the point as such and then B is the point as such. So given that A is this point, we can say that the position vector of OA is negative 1, 4. Right? And then at the same time, BA is negative 3, 6. So how do we calculate the coordinates of B? So it's fairly simple. BA is just OA minus OB. So it's just negative 3, 6 equals to negative 1, 4 minus OB. So OB is just negative 1, 4 minus negative 3, 6, which should give me a nice value of 2 and negative 2. Therefore, my B coordinates are 2, negative 2. The end. Just subtraction of vectors. And then B. They want us to calculate the magnitude of AB. But since AB and BA have the same length, right? It's just that they are in opposite directions. This one equals to BA as well. So I can just use this negative 3 square plus 6 square. Right? I'll get 45, and then square root 45 is 6.71 units to 3SF. Alright, these two are the same, they are the same magnitude, just opposite direction. So they can both have the same length. Okay, question 4. Then the rest we will do during our tutorial session together. So you have this entire triangle over here. Okay, okay, let me draw more accurately. O, D, C, right? And then here is B. A, B, and D. Here is A, here is B. So they want us to express as simply what is AB. So A to B is here, right? You want to walk from A to B, you can walk from A to O first, and then you walk from O to B, right? But since we are given OA and not AO, we can flip this to become AO plus OB. So we get negative A plus B. That's the answer over there. Or you can even just write it as B minus A. So that's the answer for part AI. II. Do you want to walk from B to D? And the question tells you that, what does the question tell you? BD. you want to walk from B to D, you can walk from B to M and then M to D. Agree? Right? You can walk from B to M and then M to P. And then the question tell you that MB equals to B minus 2A. Therefore, BM is just negative B minus 2A. So here to here is negative bracket B minus 2A. And then MD is 3B minus 2A. So here is 3B minus 2A. Therefore, BD is just walking from B to M and then M to D, which is just adding negative B minus 2A to 3B minus 2A. So you get negative B minus 2A plus 3B minus 2A. Therefore, your answer is 2B. So here is 2B. Okay? Now C. Show that CD is 3B minus 3A. So CD is this line over here. And if you want to walk from C to D, you can walk from C to M and then M to D, right? You already know what's D. And the question tell you that CM, okay, wait. Let me just write it here. If you want to walk from C to D, you can walk from C to M and then walk from M to D, of which MD we already know. And then the question tells you that AM equals to MC, right? Therefore, MA equals to CM. So we can replace this with equals to MA plus MD. And what is MA? MA is here. And MA is essentially just walking from M to B and then B to A. Right? So you will change this again. So now it becomes walking from M to B and then B to A. Then plus MD. So MB, okay, MB is given by the question. MB is B minus 2A plus BA. BA is what you have found earlier on, right? BA is just negative AB plus MD. MD is given the question by as such. So you just add all the values together. You should get negative, so it's plus negative B minus A plus 3B minus 2A. So you should get B minus 2A minus B plus A plus 3B minus 2A. Therefore, the final answer should be 3B minus 3A. And yep, so that's what the question wants to see. Sure. So 3 key steps. First key step is identifying this. Second key step is breaking down into this. And then the third key step is to changing BA to negative AB. Okay, that is for question B. C. Show that the triangles AOB and OCD are similar. So just look at this. OCD and AOB. So this is just congruence and similarity lah. So angle AOB equals to angle COD. Right? They have the common angle. And then, therefore, there's one A. What is another A that you can tell? Another A that you can tell is that since CD is parallel to your AB. Okay, so over here, you see that AB equals to B minus A, right? And CD equals to 3B minus 3A, which means is 3 bracket B minus A, which means is 3AB. So since CD is 3 times of AB, we can conclude that CD is parallel to AB. And since CD is parallel to AB, we can say that angle OBA equals to angle ODB or ODC. Right? OBA equals to angle ODC. Why? Because since now that the fact that these two lines are parallel to each other, that gives us corresponding angles. CD is parallel to AB. So now you have two reasons, right? Hence, triangle OAB and triangle OCD are similar. AA similarity test shown. Okay, so that is how you answer this question. It's just to identify this. If you cannot identify this, you will not be able to solve the question. You need to show that CD is parallel to AB. Okay, last one. So they say find the ratio, right, of the area of triangle OAB to the quadrilateral ABDC. So essentially they want area of triangle AOAB over area of ABDC. And ABDC is just area of triangle OAB over area of triangle ODC minus triangle OAB, right? So let's find out what is area of triangle OAB over area of triangle ODC first. This one is just comparing the length of the corresponding sides. So the two corresponding sides are AB and CD, right? And then you square it. So we know that CD is 3 times of AB. Therefore, over here, the fraction should be 1/3 squared. Gives us 1/9. Therefore, OAB is 1 unit, ODC is 9 units, and therefore, area of ABDC is 9 minus 1 is 8 units. Hence, therefore, ratio of triangle OAB to ABDC area is 1:8.
Okay, so for question 5, we have a quadrilateral, not specified what type of quadrilateral this is, so it doesn't really matter. Just know that it's 4 sides. Okay, so they say express in terms of A and C, give your answers in the simplest form. You want to find OP. So for this vector, if we were to draw it out, so I recommend you draw out vectors, especially for at least for 2D vectors, right? It's very easy to draw out. Then it's very easy to visualize also. So A, B, C, O, phi C, and then here is P, where AP to PC is 4:1. So here is 4, and then here is 1. Okay, so they want to find OP. OP is here. They want to find this vector. So if you want to walk from O to P, you can walk from O to C, then C to P. So therefore, for I, OP can be represented by OC plus CP, right? And we know that this is just the opposite of negative PC. So we need to find what's PC first. Then that's where this knowledge comes in over here. So we know that AC is just OC minus OA, which is just 5C minus 5A. So therefore, PC is 1/5 of AC, which means it's 1/5 of 5C minus 5A, which gives us C minus A. So you know that over here, this over here is C minus A, this vector PC. So if you want to find the opposite of PC, which is CP, so CP is negative PC, right? Because the direction is opposite, but they have the same length, as I was saying. So CP is just the opposite of PC, which means that it's just the negative version. So over here, you just need to flip it. So you just put a negative sign in front, and then this becomes A minus C. So therefore, your answer will be OP is just OC plus negative PC, which gives you 5C plus bracket A minus C, which therefore gives you 4C plus A. So that over there is your answer for I. Then moving on to II, they say find PQ. So PQ, wait, where's PQ? PQ. Oh, here's Q. You want to find PQ now. And they say that AQ here is 4A plus 8C. So this fairly simple, right? If you want to go from P to Q, all you have to do is to walk from P to A and then A to Q. So you just need to find what is PA. So essentially PQ is just PA. You walk from P to A, then you walk from A to Q. And you know that AQ is 4A plus 8C. So you just need to find PA. And just now we have established that your AC is 5C minus 5A. So therefore, your AP is 4 out of 5 of 5C minus 5A, which gives us 4C minus 4A. Therefore, PA is just the negative version of AP, which gives us 4A minus 4C. Therefore, your PQ is just 4A minus 4C plus your AQ, which is 4A plus 8C. So 4A plus 8C. So if you add all together, you should get 8A plus 4C. So that is the answer for II. So in Math vectors is just flipping of directions and then addition, subtraction. That's it. That's it. So draw it out. It really helps a lot. Then now they say explain why PQ is parallel to CB. So explain why PQ, this one, is parallel to this one. CB. Oh, okay. My drawing is a bit off, but not exactly the same as this. But they explain why are they parallel. Right here is 10A plus 5C. So just note that to prove two vectors are parallel, we must always express them in terms of scalar multiples of each other. So as you can see, for PQ is 8A plus 4C, right? Which gives us, if we factorize out the 4, we get 2A plus C. And likewise for CB, we get 10A plus 5C. Then if we factorize out the 5, we get 2, okay, here's supposed to be small a. So 2A plus C. So we can then say, therefore we can say that PQ is just 4 out of 5 of CB. Since we have shown that, they have the same vectors, it's just that they have different scalar multiples. So you can essentially express PQ in terms of CB. Therefore, your answer would be, therefore, since PQ equals to 4 out of 5 CB, PQ is parallel to CB. Yeah, just like that. It's really just like that. Since it's 4 out of 5 for CB, because when you write this, right, you're essentially saying that PQ is parallel to CB. It's just that PQ is 4 out. It's 4 units, and then CB is 5 units. So you just need to show this. This is the key over here. But then if you want to make your answer a little bit more robust, right, you can say that PQ is 4 out of 5 for CB. Therefore, PQ and CB both travel in the same direction. Then you say that therefore they're parallel. Like that can be. Okay, then for II, they say find the ratio of CB is to PQ. So yeah, so answer is 5:4. Right? CB is 5 units and PQ is 4 units. So that's the answer. Okay. So that is question 5. Next, question 6. So you have a parallelogram. Parallelogram means 2 pairs of parallel sides, but the 2 pairs of parallel sides are not equal to each other. If they were equal to each other, we call them a rhombus. That's why we say rhombus is a slanted square, and then a parallelogram is a slanted rectangle. So AB is 2P, and then BC is 3Q. Then R is, okay, I'm just going to draw this whole thing out. Okay, A, B, C, D. 2P, 3Q. Here is R. AR is 2 units, and then RD is 1 unit. Okay, so now, express RC as simply as possible. So they want R to C. They want this. So how can we find RC? We just need to find from R to D and then D to C, right? So since AB is parallel to DC, we can say that DC equals to AB, right? It's just translation of vectors because they're parallel to each other. That's one thing. And they are equal length because this is a parallelogram. Therefore, you can just say that DC equals to AB, which is equal to 2P. So here is 2P also. Then RD is just 1/3 of AD, right? Because here is 2 units, here is 1 unit. And AD is just BC. Same analogy. Because they are parallel to each other, and equal length, which is the definition of equal vectors. Must be parallel and must be equal in length. So therefore, it's just 1/3 of 3Q, which is Q. So over here is Q, and then here is 2Q. So therefore, DC is just Q plus 2P. The end. Move on. BI. S is a point on AD, and T is a point on CD. So we have maybe S over here, and then maybe T over here somewhere. And then they say RC is twice of ST. Okay, so change color. RC is twice of ST. Means RC is parallel to ST. This means RC is parallel to ST. So that means your ST probably is somewhere over here. This is your S, this is your T. ST, right? Then this is twice, this is 1. because RC is twice of ST. So they are parallel, just at different length. So they say, hence, show that RCD, so RCD, the big triangle over here, and the small triangle STD are similar. Okay, so now go back to your similar triangles chapter. How can you show that they are similar? Okay, I'm just gonna answer II over here so that we can see. Okay, first thing, angle RDC equals to angle SDT, right? That's your common angle. So that's one. What is another, thing that we can do? So once we have found this is A lah, right? Another thing that we can do is that we know that RC is twice of ST. So RC over ST is 2 over 1, right? Because RC is twice the length of ST. And then at the same time, what else do we know? So we know the ratio of this length. What is there any other thing that we can use to help us with this? So one is we can use AA, we can use SAS, or we can use SSS. So now we have found the common angle. We just need to prove another side is equal. So let's take a look at this ST, RC, RC and ST. So RC and ST. Okay, give me a second. RC and ST. RC and ST. RC and ST. RC and ST. Common angle, RC and ST. RC and ST. RC and ST. Actually, no need, because what we can do also is that since RC is 2 of ST, we know that RC is parallel to ST. And then we have another angle, CRD. So this angle over here, CRD, it actually corresponds with this angle over here. Why? Because they are corresponding angles. Yeah, they are corresponding angles because this line is parallel to this line, right? So they are corresponding. So another one we can use is angle CRD equals to angle TRD, because they are corresponding angles where RC is parallel to ST. Then likewise for the other side, we have a pair of corresponding angles over here also. So angle RCD equals to angle STD. Again, corresponding angles. RC is parallel to ST. So we have 3 angles. This is A, A, A. Hence, by A similarity test, triangle RCD and triangle STD are similar. So yeah lah, basically parallel lines, therefore corresponding angles. So when you're trying to prove like 2 triangles are similar, 2 triangles are congruent, right? Always think in terms of angles first, then sides, or maybe sides first, then angles. Then angles, you learn straight lines, you learn parallel lines. So you think, when you are thinking about angles, you can think about, okay, is there a straight line? If there's no straight line, are there parallel lines? And then if there are parallel lines, can I use interior angles? Can I use corresponding angles? Can I use alternate angles? Then you do this elimination. Then there's a more structured way to approach this question. Okay, so that is BI. I. Okay, then now I. They say Q is a point on BC. So Q is somewhere on BC. And, oh wait, no. I. Find the ratio, okay, of the area of STD to the parallel area of the parallelogram. Okay, so area of triangle STD is to area of your parallelogram, the whole entire parallelogram. So we cannot directly compare lah, but what we can do is that we can compare this small triangle to this big triangle first. Then we compare this big triangle to this entire parallelogram. Then after that, we compare this parallelogram to this small triangle, right? Because up until this point, we only know that this small triangle is similar to the RCD ma. So we compare the small triangles first. So area of triangle STD, you compare it to area of triangle RCD. And since you know that your RC is 2ST, that means your ratio of your corresponding sides is 1:2. That means this is 1 square is to 2 square, which is 1:4. Right? Because remember, length 1 over length 2 square is area 1 over area 2. This is the ratio of similar figures. So now we know that your area of STD is 1 unit, and then your area of RCD is 4 units. Then now we compare area of RCD to the area of your remaining, like your entire parallelogram. But again, you want to compare area of similar figures, right? You cannot compare like figures of different size or different shape. You need to compare figures of similar shape, of the same shape. So in this case, what we can do is that we can compare RCD to ACD. We can compare RCD to ACD, then ACD is half of ABCD, right? So there's another level to this. You compare RCD to ACD, to triangle ACD. So area of RCD over here is just half times base times height, right? So your so-called height, we don't know what's the height, but we know that the height over here is the common height between RCD and ACD, right? Both of them share the same vertical height. So when we compare them, we can actually remove them. So because you see half times the base over here is RD, then we don't know what's the height. But then we compare this to the area of ACD. So it gives us half times ACD, the base is AD, times height. So by elimination, we strike this out, we strike this out, we strike this out, we strike this out. So that gives us RD is to AD. And we know that RD is 1 unit, and then AD is 3 units. So here is 1:3. So here is units. So if you compare, RCD is 4 units in here, and RCD is 1 unit over here. So we go back to primary school math, we make the units the same. So here is 4 units is to 12 units, right? So now these two are the same. That means RCD is 4 units in both cases. Therefore, area of your STD is to ACD is 1:12. And we know that area of ACD, triangle ACD, to the area of the entire parallelogram is 1:2, right? Because ACD is half of the entire parallelogram. Therefore, this means that it's also 12 units to 24 units. So now we make these two the same. That means we can compare this directly with this. Hence, your answer is area of triangle STD is to area of your entire parallelogram is just 1 unit is to 24 units. But you don't write the unit, so you just write 1:24. And then that's your answer over there for II. So just bear in mind, compare similar figures need to compare same shape. Cannot compare like parallelogram to triangle. You must compare triangle to triangle. So what we did was we compare this triangle with this triangle. Then we compare this triangle with this triangle. Then we compare this triangle with this triangle, which gives us the whole thing. And then once we have the whole thing, then we compare back to this one. So we just want to find the units, like how much is each, the area of each worth in units. Then we compare. So that's the analogy over there. And it's just 2 marks. So I would expect it to be more, but unfortunately it's just 2 marks. Okay, then next. Q is a point on BC. And then, okay, so we look back here. Q is a point on BC. QAB is congruent to RCD. RCD. Okay, I'm going to erase all this. Oops. Okay, RCD. So this is RCD, and then you have Q. Q is a point on BC, where QAB. Okay, so probably Q is somewhere over here. This is Q. Then here is, yeah, where QAB and RCD are congruent. So form QR as simply as possible. Okay, wait, let me check if I'm correct. Q is a point on BC, QAB is congruent to RCD. Yep, okay, correct. Okay, so how do we form QR? They want us to form QR. Okay, so given that, okay, I'm just going to write over here. Or maybe I copy this down, make it easier. Copy, paste. Okay, easier now. Okay, so given that triangle QAB is congruent to triangle RCD, what can we say about QC and BC? So here's C lah, RCD. QC and BC. We know that here to here, like we know that here is 2 units, here is 1 unit. So likewise, over here is 1 unit, over here is 2 units, right? Congruent ma. So therefore, your QC is 2 units, and then your BC is 3 units. So therefore, QC is just 2/3 of BC. So that means it's 2/3 of 3Q, which gives us 2Q. So your QC here to here is 2Q. Okay, great. Because now we want to walk from Q to R. So we just need to find QC, and then we just need to find what is CR, right? And then earlier on in the part A, we found that RC in part A is express RC. Wait, where is the answer for RC? RC is, oh wait, no, it's not DC, it's RC. RC is Q plus 2P. So RC is Q plus 2P. Therefore, your CR is negative RC, which gives us negative Q plus 2P, which gives us negative Q minus 2P. Right? Hence, you got your answer already. Therefore, your QR, if you want to walk from Q to R, you can walk from Q to C first and then walk from C to R. So your answer will be 2Q plus negative Q minus 2P, which gives you Q minus 2P. So over here is your answer for I. Okay, so really it's just walking. Walk from Q to C and then walk from C to R. The reason why the question tell you that QAB and RCD are congruent, right, is because they want you to derive that your length of QC is the same as your length of AR. In fact, if you notice, right, QCRA is a parallelogram. It's just a parallelogram because AQ and RC are congruent to each other, as in they are parallel to each other. Yeah, so that's it for question 6. Okay, next, question 7. So you have a vector over here. You have PQ is A38. Okay, then they say the length of PQ is 5 square root 10 over 2. Find the two possible values of A. So this one is just taking PQ. If you find the length of it, you're essentially doing this, right? A squared plus 3A squared. So you get 10A square root 10A squared. So you just equate this one with this one because these two are essentially the same thing. So therefore you have 5 square root 10 over 2 equals to square root 10A squared. Right? Essentially 5 square root 10 over 2. You can bring the 2 over. So it's 5 square root 10 equals to 2 times 10 square root A squared. So if you want to find what's the value of A, you can just compare. You can just bring the 5 in and then you bring the 2 in to just have one square root on each side. So this 5, right, is just square root 25 times square root 10. And then this is square root 4 times square root 10A squared. So you get square root 250 equals to square root 40A squared. So therefore, you know that 250 equals to 40A squared. And hence, you know that 250 over 40 is A squared. Hence, A is just plus minus square root 250 over 40, which is just plus minus square root 25 over 4, which gives us either 5 over 2 or negative 5 over 2. So those are the two possible values of A. Okay, so A is not, it's just finding unknown A lah. And how you find unknown A is to equate the length of PQ in terms of A to the actual length, and then you solve for A. Then in B, they say a line joins 2 points A and B. Find AB. So pretty simple. If A is 5, 1, negative 5, 1, that means your position vector of A is negative 5, 1. Right? 0 is the origin. So if the coordinate of A is negative 5, 1, so if I draw the Cartesian plane, yx, that means your A is somewhere over here. A, negative 5, 1. And then here is your O, your origin. So if you draw a line from here to here, your vector is negative 5, 1. And then for B, it's 43, 38. So let's say B is like somewhere here. 43, 38. Here's B. So your position vector of B, likewise, is just this. So I'm just going to write here. B is 43, 38. Therefore, your position vector of B is 43, 38. Hence, if you want to find AB, you can walk from O to A. Oh no, you can walk from A to O and then O to B. Right? You can walk in this direction. Therefore, we say that AB is just walking from A to O and then O to B, which is just negative OA plus OB. And that's how you derive your subtraction of vectors. I mean, you don't have to show this. I'm just showing you this is how you derive your subtraction of vectors, because we have converted this addition of vectors to subtraction, but they all mean the same thing. So OB is just 43, 38. Then you minus away OA, so it's 95, 1. Therefore, over here you get 43 plus 5, 38 minus 1. Hence, your answer is 48, 37. That is for B. BI. Okay, then II. They say, use vectors to show whether or not C lies on this line. Okay, so this one is, now your thought process should be, okay, if C lies on the line of AB, that means, okay, I just illustrate. So this is A, this is B. If C lies on the line AB, that means AC must equals to KAB, where K is a scalar vector. It must be the case. So how can we like test whether it lies on the line or not? First thing, we need to find what is AC lah, right? We need to find what's this. So given that C is 11, 13, that means your position vector of C is 11, 13. Hence, AC is just OC minus OA, which gives us 11, 13 minus negative 5, 1. So is 11 plus 5, 13 minus 1, gives us 16, 12. Right? And then you know that at the same time, your AB is 48, 37. So can you express this as a scalar multiple of this? Cannot, right? Because there's no LCM. There's no LCM between 16, as in the LCM between, sorry, the HCF between these two is not the same as these two. Right? So you cannot lah. Hence, your answer will be, since AC cannot be expressed in the form of KAB, where K is scalar, C does not lie on AB. Or in other words, A, B, C are not collinear. Collinear. Yes. The word collinear, if you see this word in your exam, it just means on the same line. That's what they mean. That's the definition of this word. So they're not collinear. Okay, so that is for question 7. Question 8. Okay, pretty straightforward. A is translated to B. Okay, so you have a point A, right? Let me just like illustrate what this question means. So you have point A. You don't know where point A is, but you know that point A, if you translate it by the vector negative 3, 7, you get to 5, negative 2. So let's see where's B. 5, negative 2. So B is over here. 5, comma, negative 2. Right? Here is 5. Here is negative 2. And then they say if you translate it by vector negative 3 and then 7. So that means A moves to the, okay, moves along the x-axis by negative 3 units. That's what it means. And then moves along the y-axis by 7 units. So that's what it means by translation of a vector. So if A move along the x-axis by negative 3 units, okay, I need more space, so I'm just gonna bring this over here. Okay, A. Oops. A. So if A move along the x-axis by negative 3 units, that means originally A is somewhere over here, right? It moved backwards by negative 3 units. Then it reached here. Then after that, it moves along the y-axis by positive 7 units. Then it moves over here by 7 units. That's how you derive this vector of negative 3, 7. So hence the original coordinates of A will be just, so for the x intercept over here, it'll be 5 plus 3, gives us 8. So A will be 5 plus 3, comma, then for the y coordinate is just, here is 7 units. So it's negative 2 minus 7. So hence your answer should be 8, comma, negative 9. And then, yeah, that's the answer. So if you can draw this out, then it's very clear already. Translation of vectors, all it means, if you're confused by translation of vectors, right, then you don't think of it as vectors. Just think of it as moving a point if along the x-axis, y-axis by how many units. So if the vector is negative 3 or negative any number, that means it's moving to the left along the x-axis. And then if it's positive, then it's moving to the right along the x-axis. Then if the vector for the y-axis is positive, that means it's moving upwards. If the value is negative, that means it's moving downwards. Then they say, find the magnitude of, oh, okay, wait, this A. Find the magnitude of negative 3, 7. So find the magnitude, essentially, find the magnitude means find the length. So you just do your normal Pythagoras theorem. So it's negative 3 square plus 7 square, which should give us, okay, let me take my calculator over here, 9 plus 49. So it's square root 58, which gives us 7.62 units to 3SF. So that is the answer over there. Okay, so great. Moving on. Question 9. Okay, this vector question is pretty long. P is a point 4, negative 3, Q is a point negative 5, 1. Write down the column vector. Okay, so they just want you to find the vector, PQ. PQ is just OQ minus OP, which gives us negative 5, 1 minus 4, negative 3, which gives us negative 5 minus 4, 1 plus 3, which gives us negative 9, 4. So that is the answer for PQ. Okay, then II, they say R has a coordinates H. Okay, let me bring it here. R is H comma 3. Therefore, OR, your position vector of R is H3, where PR equals to KPQ, right? So we just need to sub in. So your PR is just OR minus OP, right? Then you get K times negative 9, 4, as what we have derived earlier on. So this gives us H3 minus 4, negative 3. Gives us K. We can actually multiply in the K. So we get negative 9K, and then we get 4K. So as a result, here we have H minus 4, and then 3 plus 3. equals to negative 9k 4k, which gives us h minus 4 and then 6 equals to negative 9k and then 4k. So by equality of vectors, if one vector equals to another vector, that means you can split this, you can associate the x values of the vector together and then the y values of the vectors together. So you have two equations now, of which you can do simultaneous equation. So from here, therefore, h minus 4k equals to h minus 4 equals to negative 9k. This is 1. And then for 2, you get 6 is 4k. So here is 2. So from 2, k is 6 over 4, which gives us 1.5. Then we sub k is 1.5 into 1, and we get h minus 4 is negative 9 times 1.5. Right, so h minus 4 is negative 9 times 1.5, which gives us negative 13.5. Hence, we get h is negative 13.5 plus 4, which gives us negative 9.5. So, that's the answer. H is negative 9.5 and k is 1.5 over here. And yeah, so that is II. Then in B now, we move on to the triangle. So triangle over here, OC, B, right? Here is B, here is A, here is point X, here is A. Question say OB is to BC is 2 units is to 3 units. So here's 2 units, here's 3 units. And then they say AX to XB is 1 is to 2 units. So here's 1 unit, here's 2 units. Okay, all label, all clear. So now they say express AC. So now they want us to find what is AC for BI. Okay, so one look, you know, if you want to walk from A to C, you can walk from A to B and then B to C. Right? So AC is just AB plus BC. And how do you find AB? Then now you look over here. If you want to walk from A to B, you can walk from A to O and then O to B. So if you want to walk from A to B, you can walk from A to O and then O to B. But the question never give you AO, they give you OA. So you can flip this. So it's negative OA plus OB, which essentially is your subtraction of vectors. So it's just B minus A. So AB is just B minus A. So over here is B minus A. Then BC is just 3 over 5, or rather is 3 units. BC is 3 units, and then OB is 2 units. Right, as you can see over here. Hence, BC is just 3 over 2 of B. So here is 1.5 B. Hence, AC is just B minus A plus 3 over 2B, which gives you the answer of 2.5 B minus A. So here is 2.5 B minus A. And then so that is your answer over there. Okay, so that's for I. Then we move on to II. They say express XB. Okay. In terms of A and B as simply as possible. So you know that XB is 2 units, AB is 3 units. So XB is 2 units, AB is 3 units. So therefore, XB is 2 over 3 of AB, which gives us 2 over 3 of B minus 8. Then you can just expand it out. So it's 3B minus 8. And then there's your answer over there. Then in I, Y is a point on OC such that, okay, AX YC is a trapezium. Okay, so I'm just going to draw this in green. AXYC. So AXYC. Y is a point on OC. Oh, okay. AX YC. Okay, so Y is here. This is Y. Why? Because AXYC is just a trapezium. And we know that trapezium has one pair of parallel sides only. So this is how your trapezium looks like. Trapezium looks like that. This is your trapezium. So now they want us to find XY. So this is Y now. How do we find what is XY? Now, simply put, XY can be expressed. If you want to walk from X to Y, you can walk from X to A. So you walk here first, then you walk from A to C, and then you walk from C to Y. Right? You can do that lah. So yeah, so that's exactly what we can do. So now we are just going to express XY as such. Okay, wait, give me a second. XY equals to. Wait, actually, you don't have to do that. There's a much easier way to do this. OC, Y is a point that, okay, so it's 2 is to 3. Okay, never mind. Reverse. There's a much easier way to do this. If you realize, this is a triangle over here, and at the same time, this is a triangle over here. So, you know, X triangle BXY is similar to triangle ABC, right? BXY is just a small part of ABC. So by similar triangles, you can essentially use the property of ratio of corresponding sides are equal. So that means here is 2 units, and this whole thing over here is 3 units. So that makes this over here 1 unit, right? So I mean the 1 unit is not very important, but you can tell. So the ratio of your corresponding sides between your triangle BXY and triangle ABC. Your BX over your AB, no, your XB. XB over AB is 2 over 3, right? And they are similar triangles, and they are similar triangles. You don't have to prove that they are similar. This question is only 2 marks. But as long as you can deduce that they are similar, you can use the property already. Hence, by similar triangles, we can tell that XB equals to 2 over 3. No, XY. Okay, I'm just going to write over here. XY over AC, right? Because the ratio of the corresponding sides are equal and all are 2/3. Hence, your xy is just taking your, it's just 2/3 of your AC. And we know that your AC is what we have found earlier on. AC is 2.5 B minus A. So bracket 2.5 B minus A. Just like that. So this gives us 2.5 times 2/3. We get 1/2 B minus 2/3A. And then that's your answer over there. Okay, so this question is a little bit on the trickier side, but nevertheless, if you draw this out during exams, you will hopefully see lah. So vectors, right, they always like to test similar triangles. Not only for vectors, but for chapters like mensuration also. So if you're stuck, just recall similar triangles. Just try your best to recall similar triangles as much as you can. All right. So next question, question 10. Okay, so we have a quadrilateral, and this quadrilateral is a composite quadrilateral, meaning to say it is not a fixed shape, it's made up of many different shapes. So over here, and over here. Okay, so this is B, C, A. Here is P, here is O, here is A, here is C. Okay, so A bracket. Find OP. So if you want to walk from O to P, you can, oh wait, what else am I missing? CP, okay, wait, CP. C to P is M bracket A minus C. Okay. Write OP in terms of A, C, and M. So if you want to walk from O to P, you can walk from O to C and then C to P. So OP is just walking from O to C and then C to P, which gives us C plus M bracket A minus C, which gives us C plus M A minus MC. And then that's your answer over there. Okay? Then in B, they say OB. So now we have another vector over here. OB, this over here is 4 bracket 1 minus M bracket C plus 4MA. So very, very long, but nothing to be scared about. They say show that OP and B lie on the same line. Lie on the straight line. So I will just modify my drawing over here. Your P. Okay, that means this line here is also P. So how can you show that they lie on the same line given that you know that OP is now C plus MA plus MC? So you just take OP equals to C plus MA plus MC, right? At the same time, OB is 4 bracket 1 minus M bracket C plus 4MA. So you just expand everything out for the OB first. You get 4 minus 4MC plus 4MA. And then you factorize out everything. You get 4 bracket 1 minus 4C plus 4A. Right? And then you just rearrange this. So you get 4 bracket 1 plus 4A minus 4C. No. What am I doing? You factorize out the 4. So here should be 1, 1. Yes. So therefore, you will get, this should be minus. Okay, now makes sense. So now you get A. No, you get A 1 plus A minus C. Okay, makes sense. Like that. 1 plus A minus C. Which then equals to 4 OP. So therefore, since OP equals to 4 OB, sorry, since OB equals to 4 OP, where 4 is a scalar multiple, O, P, B all lie on the same line. And then, yeah, that is your answer over there. This is M, apologies, M. So this is M plus MA plus MC. Yep. Then later when you times your 4 in, this one gives you your C over here. Okay, so that's the answer for I. Then II. They say CB equals to KA. So C to B here is KA. So it's just A, but multiply with a scalar lah. And then since this is A and this is A, that means CB is parallel to OA. So from here you can tell that CB is parallel to OA as CB equals to KOA. Because OA is A ma. So find the value of M and the value of K. So far we have this lah, right? OCB equals to KA. And then so far we know that your OPB all lie on the same line. So how can we find what is the value of A? Okay. Okay, give me a second. Okay, so what we can do is that CB, if we want to walk from C to B, we can essentially walk from O to C. No, we can walk from C to O and then O to B, right? If we want to walk from here to here, we can walk from here to here and then walk from here to here, right? Because what gives us this clue is that in the previous part, we show that OPB all lie on the same line. So essentially, we can derive the equation of, we derived the equation of OB previously. So we can think in this direction since we know the equation of OB now. So we can say that you want to walk from C to B, you can walk from C to O and then O to B, which essentially is just negative OC plus OB, which is just your subtraction of vectors. So you just sub in all of your values. So OB as what you found, okay, wait. Your CB, the question says is KA, right? And then your OB, as what you found earlier, is just 4. Okay, I'm just going to copy this. 4 bracket 1 minus M, comma, bracket plus 4 MA, right? And then you minus your OC. So your OC is C lah, over here. So you just expand out everything. You get 4 minus 4MC plus 4MA minus C, right? So KA is just bracket 4 minus C, bracket minus 4MC plus 4MA minus 4MC, bracket plus 4MA. 3 minus 4. Okay, yep. Okay, then afterwards you can further simplify this. So you have your 4MA over here, and then you have your A over here. So first thing we can do is that we can form a simultaneous equation where your KA equals to 4MA. Therefore, K is 4M. That's the first thing that we can derive. The second thing that we can derive is that here we have a plus 0 lah. It's an imaginary plus 0. So over here, we have 0 equals to 4 minus C minus 4MC, of which you can get 4 minus C bracket 1 minus 4m. Hence, your 4 equals to C bracket 1 minus 4m. C4 1 minus 4m. Correct? 4m. Okay, wait, give me a second. Let me see this equation over here. K 4m 4ma 4ma. Okay, this is 4ma 4ma, and then 4 bracket 1 minus mc. So here we get 4 mc minus c. 4 c. Okay. Got it. 4. Okay, mistake. So here should be 4c. Here should be 4c. Here should be 4c. 4 times this. So here is 4c. Okay, now it makes sense. So therefore, here we should get 0 equals to 4c minus c minus 4mc. That means 0 is 3c minus 4mc, right? And therefore, 0 is c bracket 3 minus 4m. But we know that c is not 0. C cannot be 0 because it's a vector. Hence, we come here and say, since c cannot be 0, we derive that 0 equals to 3 minus 4m. Therefore, you solve for it over here. So you bring this down over here, and then you bring this down over here. Hence, from here, you derive that 3 equals to 4m. M is just 3 over 4. Then you sub m is 3 over 4 into k equals to 4m. And then you derive that k is just 3 over 4 times 4 gives you 3. So these are your two values over here. All right. Then I. So they say write down the ratio of CP is to CA. So we come back to our drawing over here. CP is to CA. So now you want to find what is this ratio over here. So how can we find the ratio over there? The question never tell us, never tell us much, but we know that our value of m now is 3 over 4, right? So we know that our CP is initially m bracket a minus c, which is now 3, 4, a minus c, which gives us, and we know that CA initially, CA, this entire thing over here, we found it to be a minus c. So it's just 3/4 of AC. Hence, your CP, the 3 units comes to here, 4 units comes to here. Hence, CP is to AC is 3:4. Just like that. By finding the m value. Okay?
For question 11, ABCD is a parallelogram. So if we were to try to visualize this, it will probably look something like this, right? This is the parallelogram. Parallelogram is a slanted rectangle. So yeah, just bear that in mind. Okay, A is 97, 91. B is 94, 5. Not drawn to scale, okay? And then B, A, B, C, D. And then BC here, the vector is 892. So they want us to find the length of AB. Length of AB is fairly simple. First thing you need to do is to find your vector. So AB is just OB minus OA. So it's the position vector of B minus the position vector of A. And it's just -4, 5 minus 97, 91. So you have 3, 6. Therefore, your length of AB, or essentially is you mod the 3 over 7, you will get square root 3 squared plus 7 squared. Right? Yes, give me a second. OB minus plus minus x y. Yeah. Yep, okay, all good, all good. So therefore the answer is just 6. I don't know why I wrote 7 here. I was wondering why I got 7. Therefore the answer is 3 square plus 6 square, square root it, you get 6.70820 units. Therefore, you get 6.71 units. 23 SF. Right, that's the length of AB. Then moving on, equation of line CD. So remember, equation of line, you always need two things. You always need gradient and one pair of coordinates. You will always need this. So what's the gradient of the line? You know, you need to essentially find what is the gradient of CD, and also you need to find out what is one point that lies on CD. So given that BC equals to OC minus OB, OC is just OB plus BC, right? You can just bring this over. Therefore, OC is just -4, 5 plus 8, -2. This will give you 4, 3. Therefore, C is, the coordinates of C is 4, 3. Right, that is your coordinate of C. So that's one point that lies on this C lah. Then, how do you find the gradient of CD? Given that in a parallelogram, these two sides are parallel and these two sides are parallel, that means your gradient of CD equals to your gradient of AB, right? As CD is parallel to AB in the parallelogram. Yeah, so you just got to take note of that. So therefore, the gradient of CD equals to the gradient of AB, which is just taking the 2 points minus the 2 points, right? Y2 minus Y1 over X2 minus X1. Your A is -7, -1, and then your B is -4, 5. Therefore, you just take 5 minus -1 over -4 minus -7. As a result, you get 6 over 3, right? And therefore, you get 2. Therefore, the equation of CD is just y minus y1 equals to m bracket x minus x1, y minus sub in the coordinates of C, 3 equals to 2 bracket x minus 4, y minus 3 is 2x minus 8, y equals to 2x minus 8 plus 3, y equals to 2x minus 5. So that is the answer over there. Then in part C, oh damn, this is 4 marks. Okay, I didn't know that. But, pretty easy 4 marks to earn. Alright? Now, X is the point where the diagonals of the parallelogram intersect. So what that means is the diagonals of the parallelogram. So this is the diagonal. And this is the diagonal. And over here, is where x is. So what do you know about, what can you infer about this? You can infer that these two are equal, these two are equal. So they say find xc. How do you find xc? You can find xc by a few ways. There are a few ways to find xc, but the easiest way is you know that c is just, what is c? C is just 4, 4, 3, right? 4, 4, 3. So xc is just half of ac, if you realize, because x is the midpoint of ac. Therefore, x towards c is just half the value of a towards c. Therefore, it's fairly straightforward already. Your xc is just half of AC, which means it's just half of OC minus OA, right? And you know that C is 4, 3, so it's just half of 4, 3 minus, then OA is what? OA is 97, 91, so it's minus 97, 91, bracket, close bracket. So half, you get 11, 4, like that. Therefore, your answer should be 5.52. So, or you can just write 5.5, 2. So that is XC for you. Okay, then in II, they say find the position vector of x. So they want to find OX. So OX, you know that XC equals to OC minus OX. Therefore OX is just OC, OX is just OC minus, XC is OC minus OX. You want to find OX. So you just take OX is just OC plus, no, my brain is not braining. OX, you bring it here. Okay, wait a minute, let's just do it slowly. Okay, you want to find OX. So OX plus XC is OC. OX is OC minus XC. Yes, great. So that means you get OC is 4, 3. Then our earlier answer is 5.5, 2. Therefore, you should get negative 1.5 and then 1. Voila. That is the answer over there. Alright, so yep, that is the answer for question 11. Moving on to question 12. Okay, so your position vector of OR is -4, 5. So you can say that OR is -4, 5. And at the same time, you can conclude that the coordinates of R is -4, 5. At the same time, OS is 3, -1. Therefore, S is 3, -1. So in IA, they say find the vector that represents the translation from R to S. So essentially, they're asking you to find what is RS. Okay, they're just asking you to find what's RS. So it's just OS minus OR. So you have 3, -1 minus -4, 5. Therefore, you get 7 and 96. So yeah, that's the answer. That's literally it. Then B, find the magnitude. So they want to find the magnitude of RS. So it's just magnitude of 796. So you have square root 7 square plus 96 squared. So you just key this into your calculator. square root, you get 9.2195 ... units, which gives you 9.22 units, 3SF. Okay, so that's the answer. Next, II. Position vector of T, so OT, is K7, meaning T is K, 7, right? And then they say ST is 10. So ST is 10, means OS minus OT. Okay, never mind. So say find the two possible values of K. So we know that ST equals to OT minus OS, right? So you have 4, 7, and then OS, the question give us is 3, -1. So that means we end up with K minus 3 and 8. So that means when you find the length of T, you essentially find the length of this vector over here. ST, you essentially find the length of this vector. That means when you square root K minus 3 square plus 8 square, you get 10. Remove the square root, you have K minus 3 square plus 64 is 10 squared. Essentially it's 100. So K square minus 6K plus 9 plus 64 is 100. K square minus 6K plus 9 plus 64 minus 100, you end up with minus 27 is 0. So you solve for the value of K. Now this one is just your quadratic. So it's K square minus 27 minus 6K. K minus 9, 3. Minus 9K, 3K. K minus 9, K plus 3 is 0. K is 9 or K is -3. These are your two possible values of K. And that is the answer right there. Alright, so yep. Then part B, over here. So you have a parallelogram. I'm just going to draw the parallelogram over here. So A, B, C, D. You have a line. Okay, and then here is F, here is towards here is Q, and then towards here is P. So AF is 1 unit, AB is 2 units. So you know that F is the midpoint, right? If A to F is 1 unit and A to B is 2 units, then F is the midpoint. Then B, here is G, here is 3 units, and then here is 1 unit. Okay, now let's solve the question. They say express CD, C to D, they want CD as simply as possible in terms of P and Q. So if you realize this is a parallelogram, right? That means if you want to walk from C to D, you can actually walk from C to G, then G to P, and then P to D. Right? You can walk from C to G, then G to P, and then P to D. But if you cannot see this, it's fine, because what you can do is you can walk from C to G, then G to A, and then A to D. So CD is just walking from C to G, then G to A, and then A to D, right? And you know that C to G, you compare this vector, this one over here, to this vector over here. Your CG is just the, okay, first off, CG is 1/4 the length of AD, right? That's 1. So CG is 1/4 the length of AD. And at the same time, CG is in the opposite direction of AD, as you can tell. Right? They are in opposite directions. Therefore, CG is negative 1/4 AD. So CD is just negative 1/4 AD plus GA plus AD, which is just GA plus 3/4 AD. Right? And GA is Q. And then AD is P. So it's just 3/4 P. So that is the answer right there. Let me do a last check. AD GA plus AD G to A. Oh, apologies. A to G is Q, right? So A to G is Q. Okay, I'm just gonna write here. A to G is Q. Therefore, G to A is negative Q. So vectors, you gotta be really careful lah. So it's negative Q. So here is negative, which means you can just express this as 3/4 P minus Q. Voila, that's the answer. Okay, I. They say H is the point such that DH equals to GF. Okay, so if I were to reference back to my drawing, it will probably DGF. So GF is here, right? G to F. This is GF, and then D to H. G to F, D to H. Now that means your H is probably somewhere here, like that, where these two lines are the DH is parallel to GF and the same length as well. Something like that. Okay, this is for your visualization. So they want us to express AH. So now they want us to find what is AH. What is AH? So if you want to walk from A to H, you can walk from A to D and then D to H, right? So I'm just going to write here. If you want to find AH, you can walk from A to D and then D to H. And you know that DH is GF, right? So GF, if you look over here, is just walking from G to B and then B to F, right? G to B and then B to F. So you just write G to B and then B to F. So G to B, GB is 3/4 of, okay wait, GB is just negative 3/4 of AD. Because it's first is the length is 3/4 and then second is in the opposite direction. So you just put the negative to flip the direction. And then BF is just half, right? Half the length of BA, and BA equals to CD. So it's just half of CD essentially. So it's half of CD as well. So you have negative 3/4 P plus half of CD. CD is just 3/4 P minus Q. So as a result, you end up with negative 3/4 P plus 3/8 P minus half Q. So you end up with 3 divided by 8 plus minus 3 over 4. Okay, so you end up with negative 3 over 8 p minus half q. Just like that. And that's GF lah, right? That's GF, which is essentially your DH. Okay, then now we want to find AD. Oh, AD is just P lah. So therefore, your AH is just P plus bracket negative negative 3 over 8P minus half Q. So you end up with 5 over 8P minus half Q. And therefore, that is your answer right there. Okay? So this, I believe this entire question is probably the hardest vector question inside this paper lah. So if you can understand this, then great, because this really tackles all the fundamentals that you should know. Okay? Now moving on to the last question, question 13. Question 13. Now you have a triangle. O, D, C. Here is B. Vector here is B. O, and then here is A. Vector here is A. Now OA is 1/3 of OC. So here is 1 unit, here is 2 units. OB to DB. So it's 3 units, here is 2 units. And then they say X is a point on OC such that BX is parallel to DC. So X is adamantly is here lah. This is X. Then here is parallel, then here is parallel to each other. So they want us to find what is XD. XD. So they want us to find XD. So now if you want to walk from X to D, you can walk from if you want to walk from X to D, you can just walk from X to O, and then O to D, right? So what is essentially what is your OX? Okay, let me see. A, B, 3 over 5. 3 over 1/3 of OC. Okay, so first thing, OD is just 5 units in total out of 3 of OB, which means it's 5 over 3 of B. Right, that is OD. Now OX. Now you need to find what's XO, which is essentially just the negative of OX. So how can you find what is X? Okay, so let's look at this. OA is 1/3 of OC. OB is 3 units here, and BD is 2 units there. Okay, I got it. So it's just similar triangles, because this over here, this triangle here, is similar to this triangle over here. They are all just similar triangles, right? So in that sense, your triangle OBX and triangle ODC are similar triangles. Therefore, OX over OC equals to your OB over OD. Right? So therefore, is OX over OC is just 3 3 over 5. Therefore, OX equals to 3 over 5 of OC. So therefore, negative OX equals to negative 3 over 5 OC. And OC is just OC is just 3A. So as a result, you get XO equals to negative OX, which is negative 3 over 5 times 3A. So you get negative 9 over 5A. Hence, XD is just negative 9 over 5A plus 5 over 3B. And that is your answer over there. Okay, so this question tests you on similar triangles concept. And it's not very obvious, but if you do enough vectors questions, you'll realize that this concept has been repeatedly tested, actually quite a lot of times in the recent years as well. So yep, that's it for vectors tutorial.
So I hope that you enjoyed this crash course from vectors. Let me know what you think in the comment section below, whether it helped you, whether you found it helpful, which parts of the video that you like. And once again, if you want more crash courses just like this in the future, make sure to subscribe to this channel so that you get notified whenever I release a new crash course. I'll be subsequently releasing a crash course for every single chapter in the syllabus so that you can learn everything that you need to know in order to score A1 for math. And once again, if you want the handwritten notes that I created for this video, every single thing that I showed in this video over here, if you want the handwritten notes for that, just go and click on the link in the description below to get access to it. And if you are looking for math tuition here in Singapore and want me to personally tutor you on a weekly basis, go and click on the other link in the description below to get more information of my classes that I conduct at my math tuition center called A1 Math Academy. If not, if you take A Math and you want a full crash course just like this on differentiation, make sure to click on this video over here to check it out.